Good morning, students. Our today's topic in the topic of environment and atmosphere in the subject of chemistry O levels is water. So concentrate yourself. We are going to start. So the relative amounts of the substances which make up the human body. So here are the substances: 10% fat, 18% protein, 2% other substances, 5% carbohydrates, and almost 65% water. So the human body consisting of 65% of the water. The formula of the water is H2O. The hydrogen and the oxygen atoms are joined by covalent bonds. So this is the point to be remembered, which normally comes in the paper number 1. So the bond that is present in the water molecule is covalent bond. So the hydrogen and oxygen are bonded together with covalent bonds. The forces between its molecules are not very strong. Pure water freezes at 0 degrees C and boils at 100 degrees C. So this is the test for the pure water. So pure water freezes at 0 degrees C and boils at 100 degrees C. This test normally comes in the paper number 4 of the chemistry. Fortunately for us, this means that water is a liquid at most temperatures on Earth. The next thing that we are going to read is the properties of the water. It is colorless, odorless, and almost tasteless if the water is pure. It has a maximum density of 1000 kilogram per meter cube at 4 degrees C. It conducts electricity weakly. Many metals decomposes water, often producing hydrogen. For example, nitrogen when react with water, it produces hydrogen. The next thing that we are going to read is the water cycle. So look now. The water present in the seas and oceans evaporate because of the heat. So when it is evaporated, it is condensation process of the condensation of the water to form clouds made from tiny water droplets. So the clouds move and will come on the Earth's surface. It gets colder as the air rises. More water condenses out. The droplets of the droplets get bigger and heavier and fall as rain, hail, and snow on the Earth. Okay, when the living creatures exhale, animals breathe out water vapors. So again, it condenses and big droplets become and come back to the earth in the form of the rain, hail, and snowing. So again, plants, especially trees, lose water vapors through transpiration, which go back into the atmosphere again. So water returns to the seas via rivers and streams and underground water, and some water evaporates from the soil as well, and then the water come from the land into the sea again in the form of the lakes, canals, rivers, etc. So this is the water cycle. Next thing that we are going to read is the water as a solvent. Water dissolves a wide range of the different substances. Water is said to be a good solvent, and the substances dissolved are called solutes. So this is the question which normally comes in the paper number 1. So the thing that is dissolved is called solute, and the thing that actually dissolve the solute is called solvent. Water is a polar solvent. So very important point, it contains small positive and negative charges. Positive charges on H and negative charges on O. So small positive and negative charges contain caused by the slight movement of the electrons in the covalent bonds. So the polar solvent dissolves compound containing ionic compounds. So this is again a important point that normally comes in the paper. The polar solvents dissolve compounds containing ionic bonds. For example, sodium chloride. So sodium chloride is actually having the ionic bond, and non-polar solvents, that is For example, tetrachloromethane are poor at dissolving ionic compounds but are good solvent for molecular compounds. Compounds. So this is very important point as far as your paper number 1 is concerned. So the polar solvents are good in dissolving ionic compounds and the non-polar solvents are good in dissolving molecular compounds. A solution which contains as much as solute as can be dissolved at particular temperature is called saturated solution. If any more solute is added to the saturated solution, the extra solute remains undissolved and go and gather at the bottom of the container. The solubility of a solute is the mass of the solute. So this is the definition of the solubility now. The solubility of a solute is the mass of the solute in grams, which dissolves in 100 grams of the solvent at a particular temperature to form a saturated solution. Generally, the solubility of the ionic compounds in water, for example, potassium nitrate, increases as the temperature rises, but the solubility of the gases in water decreases as temperature. So this is another very important point as far as your paper number 1 is concerned. So the solubility of the compounds can be increased by raising the temperature, but the solubility of the gases is reduced with the raising of the temperature. A graph of the solubility versus temperature for a solute is called the solubility curve, and figure below shows the solubility curve for some common solutes. So this is another important question as far as paper number 1 is concerned. So solubility curve is the graph of the solubility versus temperature. And here are some of the solubility curves of the different substances. For example, potassium nitrate, potassium chloride, and sodium chloride. So you can see as the temperature rises, the solubility of these compounds also increases. The next thing that we are going to read is the oceans. Oceans cover about 70% of the Earth's surface. They make up just over 97% of the world's water. So these 2 points are important as far as your paper number 1 is concerned. So ocean covers about 70% of the Earth's surface. This is 1 point. And the water that is present in the oceans make up almost 97% of the world's water. We believe that life on the Earth was started in the ocean about 3 billion years ago. Since then, the chemicals in the seawater have stayed about the same. These are listed below. So here are the substances that are present in the seawater. The sodium chloride is the mass of the salt in 100 grams of the seawater. So 100 grams of the seawater contains 23 grams of the sodium chloride, 5 grams of the magnesium chloride, 4 grams of the sodium sulfate, 1 grams of the calcium chloride, and 0.7 grams of the potassium chloride. So you can see the highest proportion that is present in the ocean water is of sodium chloride, that is almost 23%. These salts have entered the oceans following their withering from rocks on the land. So when the rocks wither, so they dissolve in rainwater and come to the oceans, and where they gather. The dissolved salts are carried to the sea by rivers. So why don't the proportion of these salts build up over time? So this is another very, very important question. So over the last like 100 of the years, why not the proportion of the salts build up? So here is the answer. This is explained by chemical precipitation. A new salt entered the sea, other salts are being deposited on the ocean's floor. So more and more salts are coming from land into the sea, but the salt that is present in the sea are proportionally deposited on the ocean floors as solids. Equilibrium has been reached. So that's why the proportion is unchanged. The ocean also contains dissolved gases. These come from the volcanic activity on the seabed and from the gases in the air. So these are the two sources how gases are dissolved. The gases come from the volcanic activity and gases come from the air are being dissolved in the ocean water. The ocean plays an important part in the carbon cycle as a reservoir for carbon dioxide. So this is the reason the ocean water is a big source of dissolving carbon dioxide and how the carbon dioxide cycles maintained. The carbon dioxide can form hydrogen carbonate, which are soluble in the seawater. So this is hydrogen carbonate that is actually made by the reaction of the water with carbon dioxide. We also get carbonate ions formed. So carbonate ions are formed. These can form insoluble salts with the calcium and magnesium ions in the seawater. So already magnesium and calcium ions are present in the seawater. So when they react with the carbonate ions, so look now, when calcium ions are reacting with the carbonate ions, so calcium carbonate is made. And when magnesium ion that is present in the seawater react with the carbonate ion, make magnesium carbonate. These are called precipitation reactions. So this is the reason these compounds are depositing at the seabed. So that's why the proportion of the salts are maintained in the seawater. We are now producing so much carbon dioxide that the oceans cannot get rid of. So this is the reason. So the global warming is getting severe and severe because the human activity, more carbon dioxide is being produced, and oceans are not able to absorb all the carbon dioxide. That's why these gases are going into the atmosphere and our atmosphere is getting warmer. We are distributing nature's balance in the carbon cycle. So we are disturbing. Global warming and changing weather patterns are happening now because of the extra CO2. The next thing that we are going to read is the water in the mixture. The mixture of water and the dissolved substance that is called solute is called an aqueous solution. So when something is dissolved in the water, we have actually aqueous solution. Water is an excellent solvent. It can dissolve many substances including gases. We have seen how the ocean acts as a huge reservoir for carbon dioxide. And have you ever wondered how fish survive underwater? They rely on the oxygen gas dissolved in the water. Oxygen is not very soluble in water, but there is enough for the marine creatures. So this is how the marine creatures survive in the water. The next thing that we are going to read is the colloids. However, as you know, not all substances dissolve in water. Can you think of some examples? So look now, oil is one example that does not dissolve in water. They do not mix well and form two separate layers like this. They are immiscible, so they do not dissolve with one another and make layers. So that's why these are called immiscible. But when you shake the two liquids, so if we shake the water well, you get the blobs of the oil spread throughout the water like this. We can say that the oil is dispersed in the water. A colloid is a finely dispersed mixture of the two or more substances. This kind of the mixture is called now colloid that do not dissolve each other. If we put it for some time, again the two substances will be separated. But if they mix in this form, so this is called colloid. There are many types of the colloid. We can have any combination of the solid, liquid and gas you can think of. The shaken up salad dressing in a colloid made two liquids. We call this an emulsion. So have you ever seen the emulsion, which is actually the painted on the walls and on the houses? That is also a colloid. Colloids often have different amounts of each substance in their mixture. The main substance is called the continuous phase. The substance spread out in is called the dispersed phase. So the thing that is present in bigger amount in the colloid is called continuous phase, and the thing that is present in smaller amount in the colloid is called dispersed phase. So look now, here are some examples. So in emulsion, the continuous phase is liquid and the dispersed phase is also liquid, and examples are paint and cosmetics. So another example of the type of the colloid is sol, in which continuous phase is liquid and dispersed phase is solid. The example is toothpaste. You can see toothpaste, the main phase is the continuous phase is liquid, and in that some kind of the solid is also there, so that is called toothpaste. Another type of the colloid is liquid foam, that is actually used by the hair mousse and cream topping and shaving foams. The continuous phase is liquid and the dispersed phase is gas. The next thing that we are going to read is the sol. Sometimes it is hard to judge if a solid has dissolved in the water or is a fine suspension of the solid particles. You can tell the difference by trying to look through the mixture. So this is a very simple example to understand. Light passes through a solution. It looks clear. However, light is scattered by a sol. It looks translucent. So look now, here is a solution of the salt that is clear. The light passes through the salt solution and it looks clear. But here is a sol of the chalk powder. So when light passes through it, it is scattered. So this is a sol. Chalk water is a sol and salt water is a mixture. Water is the most abundant liquid on the earth. It covers about 70% of the earth's surface. Water is used in our homes for cooking, drinking, and washing. The water should not only be pure but safe and clean. Water from natural sources contains a variety of the dissolved substances. Rainwater contains dissolved gases like oxygen, nitrogen, and carbon dioxide. So these are dissolved into the rainwater from the atmosphere. These are naturally occurring substances. Rainwater that falls around industrial areas contain dissolved pollutants such as the nitric acid and sulfuric acid, which are the byproducts that are produced by the industrial reactions. Rainwater that falls on the ground becomes surface water, which collects in lakes and rivers. Surface water contains naturally occurring substances, for example, dissolved mineral salts and organic matter. So when the rainwater falls on the ground, it dissolves mineral salts that are present on the ground and some organic matter also in the form of the vegetables, fruits that are rotten, that are thrown onto the surface. Surface water that flows through the populated areas contains pollutants such as the sewage, metal compounds, and phosphates from the detergents. Surface water that flows through the agricultural land contains pollutants such as the nitrates and phosphates from the fertilizers leached from the soil. So the water dissolves all things and carry with it into the rivers and then rivers into the oceans. The next term that we are going to read is the deliquescence and the efflorescence. A deliquescent substance is one which absorbs water from the atmosphere and dissolve in this water. So example are here. Lump of the anhydrous calcium chloride when exposed to air eventually disappears, leaving a clear concentrated solution of the calcium chloride. So the compound is being dissolved in the water. Other examples are phosphorus oxide and sodium hydroxide. So these kind of the liquids which actually dissolve in the water, which are present in the atmosphere, they absorb water from the atmosphere and dissolve in this water. So these kind of the substances are called deliquescent. The other type is hygroscopic substance is one which absorbs water from the air without dissolving. So they absorb water, but do not dissolve. Examples are calcium oxide and copper oxide. An efflorescent substance is one which loses its water of the crystallization to the atmosphere. So this is the reverse process of the previous one. The previous one actually absorbed water from the atmosphere, but the efflorescent substances actually lose their water of the crystallization to the atmosphere. So look now the crystals of the washing soda. So here are the crystals of the water that will be actually loosed into the atmosphere. So look now, when exposed to air, crumble to a white powder consisting of the monohydrate. So can you see 9 molecules of the water has been gone into the atmosphere. Crystals of the Glauber salt is an other example, crumble to the powder of the anhydrous salt in dry air. The next thing that we are going to read is the water pollutants. Here are water pollutants, here are harmful effects, and here are the sources. The first pollutant, that is acids. The sources are acid rain of the low pH, decreasing pH of the seawater, and the effects are marine life cannot survive in low pH water. Low pH water results in the poor growth of the vegetation. The next water pollutant is the nitrates and the phosphates. So the harmful effects are causes eutrophication. This is the excessive growth of the vegetation in the water, which removes dissolved oxygen from the vegetation, dies and decays. So when eutrophication takes place within a lake, so excessive growth of the vegetation is occurred in the water. So these are actually living things. So they removes dissolved oxygen from the water, and the vegetation dies and decays. So when the vegetation dies and decays, the situation gets more worse. As a result, marine life also dies. Nitrates interfere with the hemoglobin ability to carry oxygen. The sources of the pollutant is excess fertilizers washed off from the farmer's crop. The next water pollutant is the heavy metal ions. The sources are waste from the industries involved in the mining of the metals, and the effects are poisonous to the mankind. The next water pollutant is the sewage. The sources are untreated household waste, and the effects are health problems such as the infections. The next water pollutant is the oil. Sources are oil spills from the ships, and the effects are kills marine life as the oxygen passage into the water is sealed off. So oxygen cannot go into the water from the atmosphere then. The next thing that we are going to read is the desalination. Desalination refers to the removal of the salt from the seawater. So how the seawater is removed from the how salt is removed from the seawater, this process is called desalination. One method is desalination, where pure water is distilled and collected, leaving the salt behind. So this is a very traditional way of collecting salt from the water. The seawater is thrown onto the onto the shore, and the water evaporates or go back into the sea, leaving behind the salt. Another process used nowadays is reverse osmosis, which is a very modern and expensive technique, where water is forced across the semi-permeable membrane against a concentration gradient. So concentration gradient is the process through which the molecules move from higher concentration to lower concentration through the exertion of the pressure higher than osmotic pressure in order to obtain pure water. The next thing that we are going to read is very important, that is the chemical test for the water. Water changes the color of the following chemicals. So if water is to be observed, either the water is present or not. This question is again related to paper number 4, because that paper is alternate to practical. So water changes the color of the following chemicals. So water changes the color of the anhydrous copper sulfate from white to blue. Next is water changes the color of the anhydrous cobalt chloride from blue to pink. These two tests will show that the liquid contains water or not. To test whether it is pure water, so you can find its boiling and freezing point. This is another very important question as far as your paper number 4 is concerned. So the pure water boils at 100 degrees C and freezes at 0 degrees C. The next thing that we are going to read is the water of the crystallization. Certain substances crystallize, form crystals with fixed number of the molecules of the water contained within the crystal. This water is called the water of the crystallization. So number of the molecules that are being crystalled with the compound is called water of the crystallization. For example, copper sulfate crystallizes as copper sulfate crystal, that is copper sulfate. So 5 molecules of the water are being crystalled with the copper sulfate. They are blue in color and are said to be hydrated. On heating, the water of the crystallization is evolved, and while anhydrous copper sulfate is formed. Other examples of the substances containing water of the crystallization are hydrated sodium sulfate, hydrated sodium carbonate, and hydrated magnesium sulfate. There is no way of predicting the number of the molecules of the water of crystallization in a particular substance. So this is the definition of the water of the crystallization. The next thing that we are going to read is the reactions of the metals with water. The difference in reactivity of the metals can be seen in the reactions of the metals with water. The first metal that is going to be reacted in with water is potassium. A small piece of the potassium reacts violently with cold water. It floats on the water in a small molten ball and reacts with the water, producing hydrogen gas which catches a light. So hydrogen gas is produced that catch light and burns with a pinkish flame. An alkali, potassium hydroxide, remains in the solution. And here is the reaction of the potassium with the water. The next metal that is going to be reacted with the water is sodium. Sodium reacts with cold water in a similar way to potassium, but more slowly. The hydrogen does not usually ignite. So the sodium reacts with water to form hydrogen, but hydrogen does not ignite. The next metal that is going to be reacted with water is the calcium. Calcium reacts very slowly with cold water and usually sinks. And here is the reaction. Hydrogen gas is again produced. During the experiment, the solution produced turns cloudy due to the formation of the calcium hydroxide, which is not very soluble and precipitates out. The next metal that is going to be reacted with water is the magnesium. Magnesium reacts very slowly with the cold water. It takes several weeks to produce a test tube full of the hydrogen from a short length of the magnesium ribbon. It reacts well, however, when strongly heated in steam. So hydrogen gas is produced. The process can be accelerated by raising the temperature. The next metal that is going to be reacted with the water is the zinc. Zinc reacts with steam in a similar way, and here is the reaction. The next metal that we are going to discuss that react with the water is the iron. Iron, being less reactive, reacts only reversibly with steam, and here is the reaction. So this was the lecture, students. I hope so this will be much more easy and interesting for you to understand and learn. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.